Now we're going to look at different representations of functions, including tables and graphs, and trying to come up with what the function should be and writing our answer in function notation. So for this first problem, it says that the cost to make 4 bracelets is shown in the table. How can you determine the cost to make any number of bracelets? Step 1, we're going to examine the relationship between the values in the table. Is it changing at a constant rate? What that means, if it's changing at a constant rate, is that we have some value that as the number of bracelets increase, the cost increases, right? And that number is constant. Or we can think about as we're having some sort of unit rate that's consistent. Or you can think about that we have a slope. So if we have a slope where the slope is consistent throughout, what we're ending up getting is a straight line or a linear function. So looking at this, I'm going to see how our values change and try to figure out if it's consistent. So when I compare the number of bracelets, each of these values are increasing by 1. If I compare the cost as my number of bracelets increase, I can see that the cost is also increasing by a consistent amount. It's increasing by $15 every time. Therefore, that would mean that my slope in this situation, or my constant rate in this situation, is going to be 15 over 1. Or I could just write it as $15 per bracelet. So that's my slope. That's what my constant rate is. So if I wanted to write this equation in slope-intercept form, remember that slope-intercept form is y equals mx plus b. So I have my slope already. We figured out that my slope is 15, but I don't know what my b is. So b is going to be the cost when the number of bracelets is 0, right? When the x value is 0. We'll use the method we learned last unit of writing our equation in point-slope form, where we use one of the points from the table and the slope we just found, and then moving things around to isolate y and to rewrite the equation in slope-intercept form. My final equation in slope-intercept form is y equals 15x plus 2. So what that means is when 0 bracelets have been made, I'm still paying a cost of $2. And that $2 could be something maybe like setting up the business or learning how to make the bracelets or something, but the idea is that before we've made any bracelets, we've already paid $2. So another way we could figure out this y-intercept, instead of using point-slope form and plugging it in to get whatever our y-intercept is, we also could just look at our table. So looking at our table, remember that the y-intercept is the y value when the x-coordinate is 0. So here we don't have 0 included as our number of bracelets. We don't have that data included. However, if we can tell this pattern, this relationship, that with each of these, as we count up with the number of bracelets, we increase by 1, and as we count up with the cost, we increase by 15. So if I were to work backwards and go from 1 to 0, that means here, working backwards, I would be subtracting 1 from there. Working backwards from 17, the corresponding x value, instead of adding 15, I would have to be subtracting 15. So then that means my corresponding output value when my input is 0 is going to be 2. So that's just another way you can get the same answer. I just want to show you other possibilities. So finally, the last thing we're going to do is write our equation in function notation with the f of x isolated on the left side of the equation. So we already have this nicely written out in slope-intercept form. All we're going to do is replace that y in y equals mx plus b. We're replacing that y with f of x. And that's it. That's how you write a linear equation in function notation. Okay, so we're going to do the same process, except now looking at the table, it's a little different because we have decimals. We're going to figure out how the values change with x, our input, and how they change with y, our output. So if we wanted to write our function in slope-intercept form, we need to figure out the slope and we need to figure out the y-intercept. So the slope is going to be the change in y over the change in x. The change in y we figured out is 6.5 and the change in x is 1. So I can write that as 6.5 divided by 1, which would simplify just to 6.5. Now, in the past, we have not liked to use decimals as our slope because when we graph it, the slope will tell us how we move up or down and how we move left or right. So with it being a fraction, it's a little bit easier to figure out what that means. And if we had a decimal, we would just have to go and convert it back into a fraction. With function notation, if we're not actually graphing it, it's okay to leave our slope as a decimal. It's perfectly fine. So I could just write this number here as my slope and then try to figure out what my y-intercept is. In our last unit, we figured out how to write an equation in slope-intercept form when just given points that exist on the graph. So looking at this, I'm going to rewrite it in point-slope form first, with 6.5 as my slope, and I just pick one of the points from the table to plug in, and then I just rewrite it and solve for y. In my answer, my y-intercept is going to be 0, so I can write plus 0 or just leave it out. If I didn't want to use point-slope form, I still could figure out the y-intercept by looking at the change in x and the change in y in my table. If I want to find the output value when the input value is 0, I know to go from 1 to 0, I would have to be subtracting 1. Then, to go from 6.5 to my corresponding x value, following this pattern, if I'm adding 6.5 with each value as I increase by 1 in x, then I will need to do the opposite and subtract 6.5. So when I subtract 6.5, I would also get 0 as my output. So now to write my final equation in function notation, that's just going to be f of x is equal to 6.5 x, and that's it. Now we have a graphing question. At 6 a.m., the outside temperature is -3 degrees Fahrenheit. The temperature increases by 2 degrees Fahrenheit for every hour for the next 6 hours. Write a function that models the situation. Okay, so deciphering information, we know that the temperature increasing, that's going to be a positive slope, right? Our temperature is getting warmer, and our slope is 2. Our starting temperature, or our y-intercept, is this value for our temperature, that is -3. So we could think about when we're graphing it, that would be at the point 0, -3. So writing my function, I'm going to start with my function notation, so I'll put f of x is equal to, if I'm still writing it in slope-intercept form, that's going to be like y, but in this case f of x, equals mx plus b. So m we said was 2, and then I still leave the x there, plus b, since it's a -3 as my y-intercept, I can do that as -3. So now I'm going to be graphing this. Looking at my y-axis, it's counting by 2's, so be careful when you graph it that you're putting your point in between here. So that's at the point 0, -3 on the y-axis. From there, our rise is 2 and our run is 1. So move up 2 to the right 1. And continue this all the way until you get to where x is 6. That represents 6 hours. If the temperature continues to increase at the same rate, what would the temperature be at 2 p.m.? So from 6 a.m. to 2 p.m., if we go from 6 to 12, that's 6 hours, and then plus 2 more hours, that's going to be 8 hours. So this question is basically asking when x is 8, what is y? Or when our input is 8, what is our output? We also could think about it in terms of function notation, which is what we have been learning. What is f of 8? If we know that f of x is 2x minus 3, then f of 8 is going to equal 2 times 8 minus 3. So that's 16 minus 3, or 13. So the temperature at 2 p.m. is going to be 13 degrees Fahrenheit. Our last question is, does the linear function realistically represent the temperature for the domain where the x values are in between 0 and 24? Explain.